All right, we reached the top of the mountain and we're coming back the other side. So things should start to feel a little bit easier now. So the next concept that we're going to review is solution. So solution concentrations, which are given as molarity in chemistry. So molarity is equal to moles of solute divided by liters of solution. So the units for molarity are moles per liter, but we abbreviate this to capital M, calling it molarity. So the molarity of a substance can be indicated with square brackets. So for example, the concentration or the molarity of hydrochloric acid is 1.0 molar or moles per liter. There's lots of different ways of describing this. Now, it's a nice little triangle. Molarity is equal to moles divided by volume. Volume is equal to moles divided by molarity. Or you could say that moles are equal to molarity times volume. So if they ask you a question like, find the molarity or find the concentration of a solution by dissolving 0.5 moles of lithium bromide in enough water to make a 150 milliliter solution, they are asking for the concentration or the molarity of the substance. So molarity will equal moles divided by volume in liters. So they've given us that it's 0.500 moles of lithium bromide in a point or 150 milliliter solution, which there are 1,000 milliliters in a liter, right? So this is going to be 0.1500 liters. So then the concentration is just going to be simply 0.5 divided by 0.15, which gives you to 3 sig figs, 3.33 molar or moles per liter. Both would be absolutely acceptable. And then we can switch this around. We can say find the molarity of a solution by dissolving 5 grams of potassium chloride to make a 100 milliliter solution. And for this one, we first have to convert from grams into moles. So we would say that we have 5 grams of potassium chloride, and we are going to convert that into moles. So 1 mole of potassium chloride weighs what? Well, potassium is 39.10, and there's 1 potassium ion, and then chlorine is 35.45. So then we would say that the molar mass of potassium chloride is 5 divided by bracket 39.1 plus 35.45 unbracket equals, and we would get 0.067069 dot dot dot. Now you'll notice, right, this is technically 3 sig figs, but I'm not at a final answer. This is moles of potassium chloride, and I'm going to use this again. So maybe you store it as A, or maybe you know that this is going to be the previous answer in your calculator. But now to find molarity, we're going to do moles divided by volume. So we're going to put that recall A, or that 0.067069 dot 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 divided by 100 milliliters in liters is 0.1000, maintaining sig figs. And then I'm going to my calculator has that answer in it. So I'm just going to go divide it by 0.1. And that is going to give me a concentration of 0.671 to 3 sig figs molar, right? And so then this would be the concentration of potassium chloride. Awesome. Okay, last one is using, which is kind of what we're going to do next, but we are going to use molarity to then determine moles to then determine mass. We're kind of going to go the opposite way. So we want to know the mass of sodium chloride required to make 50 milliliters of a 2.5 molar sodium chloride solution. So the first thing we have to do is find moles. So the formula for moles is moles equals molarity times volume. So you're going to take that 2.50 and you're going to multiply it by 0.0500 liters. So 2.5 times 0.05 is going to equal 0.125, and this is the moles of sodium chloride. And now what we have to do is convert from moles of sodium chloride into grams of sodium chloride. So I'm going to do that over here. So I've got 0.125 moles of sodium chloride. I should have spaced this out different. Okay, where 1 mole of sodium chloride weighs 30, no, sodium's 22.99. What is sodium? Yeah, so 1 sodium, which is 22.99, plus 1 chlorine, which is that 35.45. So I'm going to type into my calculator 0.125 or answer times bracket 22.99 plus 35.45 on bracket equals, and I'm going to round this answer to 3 sig figs, so I get 7.305, but I'm going to round this to 7.31 grams of sodium chloride. And you want to kind of make sure that you're clear where your answer is, especially because I went with a calculation. The first thing I did was calculate moles, and the second thing I did was calculate grams. Just make it really clear where your answer is.